So, first part about motion is about changing my position. That's my distance or displacement. Next up is how quickly my position changes, and that can be defined with speed and velocity. There are multiple ways that you can define how quickly your position changes. We can talk about averages, which is looking at the entire time of travel, or we can look at instantaneous, which is how fast you're going at a single time. These definitions all seem very similar, so let's break them down. The average speed is the total distance traveled divided by the time it takes. And we have an equation here. Speed is distance divided by time. Instantaneous speed is how fast an object is moving at a moment in time. So it's like what your speedometer says on your car. Average velocity is different from speed because it looks at your total displacement divided by the time it takes. So your average velocity is equal to your displacement divided by time. And your instantaneous velocity is the same as your instantaneous speed, but with a direction. So instantaneous speed and velocity are the same, except for velocity always has a direction. All right, the SI unit for speed and velocity is meters per second. This is important to remember. Now, how do we get that? Well, speed is distance divided by time. Distance is measured in meters, and time is measured in seconds. So in the equation itself, I can see that speed is measured in meters per second. So we can go back to Chesterfield Town Center from school. And the question is, what is the average speed from the time you leave school until you get to Chesterfield Town Center? For that, we just take the distance and divide by the time. So the distance traveled is 4.3 miles. And let's say what's your fastest average speed? That'll be when it only takes 9 minutes. It's about half a mile per minute, which is about 30 miles per hour. Now, you are not actually driving 30 miles per hour this entire time. We have stop signs, we have to speed up, we have to slow down. Parts of this route have a speed limit of 45 miles per hour. But when you average all of that together, you get an average speed of 30 miles per hour. Now, the average velocity is displacement divided by time. So the displacement in a straight line is shown here on the picture, 2.97 divided by 9 minutes. And for that one, you get 0.33 miles per minute. Which is about equal to 20 miles per hour. So if you could travel in a straight line, then your average velocity would only be 20 miles per hour. And let's say southwest. You could go slower and get there in the same amount of time as somebody who takes the route that's shown. When you zigzag back and forth, you have to travel faster than somebody that can travel in a straight line if you're going to get there at the same time. All right, here's some more. You're going to the beach on I-64. If it's 100 miles and you want to get there in 2 hours, what is your average velocity? All right, so average velocity, displacement divided by time. So my displacement is 100 miles, but remember, displacement needs a direction. Which way is Virginia Beach? Let's say it's to the east. And my time is going to be 2 hours. So V is equal to 100 miles east. I divide by 2 hours, and I get that it's 50 miles per hour to the east. If I were to drive 50 miles per hour towards the west, I'd end up in the mountains. So direction is important. All right, let's say you immediately get to the beach, but you turn around and come home, but there's a backup at the tunnel, like there usually is, and it takes you 3 hours to get home. What is your average speed for the entire trip? I'm looking for the average speed. Average speed is distance divided by time. So if you start at school and you drive all the way to the beach, it's 100 miles. And it took 2 hours. And you drive all the way back. So 100 miles that way. And it took 3 hours. The average speed is going to be 200 miles over 5 hours, which is hopefully 40 miles per hour. Now, your average velocity is your displacement divided by time. So if you start here and you finish here, your displacement is 0. So your average velocity is 0. You could think of this in a little bit of a different way. You could think that all velocities towards the east are positive and velocities towards the west are negative. And what you'll get is that these two velocities will cancel out. And that's why your average velocity is 0, even though you were moving the whole time.